Yes, you're welcome. Thank you for viewing our videos. Thank you for using QuestLift. And thank you for loving chemistry. This is our new topic of organic chemistry. We want to look at alcohols and phenols. Certainly, alcohols is a common word that we usually use in our vocabulary. But today we want to look at chemically what we mean by alcohol, and then later we shall learn what we mean by phenol. In this lesson, I will simply be introducing what alcohols are. Now, alcohols refers to any organic compound that contains the hydroxyl group as their functional group. So we are saying that alcohols are organic compounds that contain the hydroxyl group as their functional group. Hydroxyl group as their functional group. What do we mean by the hydroxyl group? Hydroxyl group is the OH group. So you will see compounds with the OH group attached on the carbon chain, and that is an alcohol. For example, the common alcohol that we know is ethanol. If you read the structure of ethanol, it will be CH3, CH2, OH. So the presence of the hydroxyl group attached onto one of the carbon atoms in the carbon chain makes this compound to belong to a homologous series of compounds that we call alcohols. It is common that many of us know ethanol as an alcohol, but not all alcohols are ethanol. There are quite many other alcohols, as we shall be seeing, according to the number of the carbon atoms. Now, since there are very many other alcohols, it is important that we learn how to classify these alcohols. And one of the ways we can classify these alcohols is depending on the number of hydroxyl groups present on the carbon chain. Now, depending on the number of hydroxyl groups, alcohols may be classified as monohydric, dihydric, or polyhydric. So, we can say that alcohols are classified as monohydric, dihydric, or polyhydric, depending on the number. Depending on the number of hydroxyl groups in the carbon chain. We shall give some of the examples on each of the following categories. For example, if we look at the monohydric, now because of the word mono, that prefix simply means these alcohols have only one hydroxyl group attached within the carbon chain, and these are very common. These are very common, including our own ethanol. One hydroxyl group attached in the carbon chain, the compound will be called a monohydric alcohol. These have one hydroxyl group, in the carbon chain. In the carbon chain. And these are very common. So you will get an example, ethanol, CH3, CH2, or H. That is one example. We shall be seeing more of this. Then we have the other category. This is Roman 1. Category 2 is dihydric. Dihydric alcohols. Now, if monohydric means they have one hydroxyl group, then dihydric they have two hydroxyl groups. So these have two hydroxyl. These have two hydroxyl groups within the carbon chain. Two hydroxyl groups within the carbon chain. And if these have two, then we can give an example here. You have CH3, CH, CH2, or H. That's one example. Another popular one that we even saw in alkenes, two hydroxyl groups. We called this one ethane 1,2 diol. That is a common one. And then this one would be propan 1,2 diol. These are dihydric alcohols because they have two hydroxyl groups attached onto the carbon chain. And then we have the third category. The third category. These are called polyhydric alcohols. Polyhydric alcohols. These have more than two hydroxyl groups in the carbon chain. In the carbon chain. What does that mean? That means they could have 3, 4, and so on, OH groups. Now, the common example here that we normally look at is the glycerin. You have CH2 or H, CH or H, C or H. This is commonly called glycer. This is commonly called glycer. Very common alcohol, especially a residue in the manufacture of soap. Common alcohol. And the IUPAC name for this is propan 1,3 triol. This is an example of a polyhydric alcohol because it has more than two hydroxyl groups within the carbon chain. Now, according to the number of hydroxyl groups, that's the way we can classify alcohols. However, in our discussion of this topic, alcohols, we shall be more concerned with the monohydric alcohols. We are going to discuss the monohydric alcohols in quite more details. And so, I want us to look at the monohydric alcohols in more details. Monohydric alcohols as we said, they contain one hydroxyl group within the carbon chain as the functional group. That's what makes them alcohols. The functional group for these alcohols must always be hydroxyl group. And if it is only one, then these are called monohydric alcohols. Now, we would need to know their general formula. How are they represented? They are represented by the general formula. They are represented by the general formula. They are represented by the general formula ROH, where R is the alkyl group. R is the alkyl group, meaning that you have the carbon chain to which one OH is attached. Also, we can represent them by the general formula CnH2n plus 1 with an OH, where this whole group is an equivalent of the alkyl group. So this formula and this can be applied, and this is more applicable when it comes to calculations. Although some people would represent the general formula as CnH, we would add this H to this, and then that would make them how many? This would be C, this is 2N plus 2 and the O, because we are now adding this H here. So, either way, if we can remember that alcohols are represented as ROH, this is a better way of representation, to always know that there must be a functional group called the hydroxyl group. Now, these monohydric alcohols can be classified into what we call classes of alcohols. So we are going to look at the classes here. Classes of monohydric alcohols. In all our discussion, we shall be referring to these classes, and therefore it's very important that we understand the classes of monohydric alcohols. So when we shall be talking about classes of alcohols, we shall be specifically referring to those of monohydric alcohols. So the first class, number one, we call them primary alcohols. There are different ways that we can define primary alcohols. However, one thing that's very important, we shall be emphasizing the carbon atom to which the hydroxyl group is attached. There are certain features that we look for on that carbon atom to which the hydroxyl group is attached. Now, for the primary alcohols, the carbon atom to which the hydroxyl group is attached must have always two hydrogen atoms on it. So we shall say that these are alcohols in which the hydroxyl in which the carbon atom to which the hydroxyl group is attached has 2 hydrogen atoms. Has 2 hydrogen atoms and 1 alkyl group. So let's look at the formula and then we see what we mean. They are represented by the general formula. They are represented by the general formula. RCH2OH. So when you look at the general formula, the carbon atom to which the hydroxyl group is attached has exactly 2 hydrogen atoms, as we are saying, and 1 alkyl group. An example is our very own ethanol. This alcohol has the hydroxyl group attached onto the carbon atom that has only 2 hydrogen atoms in that structure. And there is 1 alkyl group, the methyl group, attached to the carbon atom with the hydroxyl group. Very many examples would be given in that respect. If we had propane, 1 ol. This is another. The carbon atom to which the OH is attached has only 1 hydrogen, has only 1 alkyl group. In this case, the alkyl group is this, and 2 hydrogen atoms attached on that carbon atom. So that makes those the primary alcohols. The other category is the secondary alcohols. Now these have 1 hydrogen atoms attached on the carbon with the hydroxyl group and 2 alkyl groups. 1 hydrogen atom and 2 alkyl groups. So in this case, you look at the general formula. General formula as R2, if they are the same, CHOH. Or if they are different alkyl groups, then we have RCHOH, different one. So in this case, the carbon atom where the hydroxyl group is attached has 1 hydrogen atom and 2 alkyl groups. Common example, we have CH3CHOH, CH3. So in this case, we are looking at an alcohol where there is 1 methyl group, another methyl group attached onto this carbon atom with 1 hydrogen and an OH as per the definition. Now in the next video we shall be looking at more of these classes of alcohols to even look at the tertiary and then more examples. Still introducing what we call alcohols. Thank you, don't miss.